Okay, go to page 225. And I want you to look at number 24. All right, 24 has us putting together sodium and a polyatomic ion called nitrate. Now, one of the things here that is going to get you right off the bat is the difference between the normal ending for a single ion, like nitride. We came across that one earlier, which means we linked it to nitrogen. But when you see this ATE ending here, this is a dead giveaway to you that it's not coming from the element, but instead it's coming from a polyatomic ion chart. Look on page 224 at that big table. See if you can find a polyatomic ion on that table called nitrate. You find it?
Yeah.
All right, what's its formula? For nitrate? It's what? NO3 minus, right? Okay, so sodium is Na, and nitrate is NO3, how many? What's the charge on it? Right, 1 minus for the whole group. Remember, if I wanted to put a circle around it, that would show that it's the whole group we're talking about here. What's the charge for sodium ion? 1 plus. That's just right from the periodic table. Now, do these two balance out to equal 0? Absolutely. So what is the ionic formula for sodium nitrate? It's Na, NO3. Okay? The positive and the negative charge cancel out, which means you don't have to write them in the ionic formula. You don't write them in the ionic formula. And we don't put the polyatomic in parentheses because we only need one of them. Let's look at number 25. All right, we're putting together a calcium ion and chlorate. Again, there's that ATE ending on the end of chlor. So that means you got to go to that table and you got to search around until you find something called chlorate. CI? CL, right. ClO3. So we have calcium. What's the charge on a calcium? 2 plus. And then chlorate is ClO3. What kind of charge? 1 minus, right? All right, so here we go. We have a calcium worth 2 plus, a chlorate worth 1 minus. Think, put it in this mindset. How many chlorates would I need to balance out a calcium? 2. So what we're going to do in the formula is we're going to put calcium. We know it has a 2 minus charge, but we need 2 chlorates. So is that cool if I do it like that? What's wrong with that?
Because then it looks like it's 32.
Yeah, it looks like ClO32. It's not ClO32, it's ClO3, but I need 2 of them. So I put parentheses around ClO3, put the 2 outside, showing I need 2 1 minus charges to balance out the 2 plus. And that's its formula. You'd say it's Ca, ClO3 in parentheses, 2. That's how it's said. Questions about that? Are we okay? Mm-hmm. All right, let's do one more together. Let's do 26. 26 has aluminum coming together with a polyatomic ion called carbonate. And again, we see the ATE, dead giveaway that it's a polyatomic ion. Charge on an Al. We did this charge a couple times today already. 3 plus, right? Now carbonate, what's that thing's charge? Or it's 2 minus, and what's its formula? Okay. So on that table, when you look up carbonate, you'll find this CO3 with a 2 minus charge. All right, now here's one that's not so pretty and easy to do. Okay? What's the easiest way when the ion numbers are a little messy? Yep, you can do your crisscross method. Take this 2 minus, cross it down diagonally, take that 3 plus, cross that down diagonally, and that gives me Al followed by a positive. No, not yet. So Al is going to be followed by a 2. CO3 followed by a 3 down here. And then parentheses up, and you got yourself a valid ionic formula.